The go-fast boat world was born on a quarter-mile stretch of industrial waterfront in North Miami Beach called Thunderboat Row, shaped by one of the most competitive racing cultures in motorsport history and producing the most mechanically demanding recreational vessels on the water today. Don Arano founded Formula Marine in 1962, then Donzi, then Magnum Marine, then Cigarette Racing Team, all on the same block in North Miami Beach. Reggie Fountain won 101 of 201 professional offshore races. That lineage runs through every go-fast hull on the market today. But that reputation does not protect every configuration equally. Some carry documented mechanical and structural problems buyers only discovered after the throttles were buried. We are breaking down the 3 worst and 4 best speedboat configurations to own. Stay until the end. The best models are not what most buyers are shopping for, and that gap is exactly where the value is. The first configuration to approach with serious caution is any inboard or stern drive go-fast boat built between the mid-1980s and the early 2000s that has no documented exhaust riser replacement history. High-performance inboard engines of this era routed raw seawater through cast-iron exhaust risers to cool outgoing exhaust gases. Internal corrosion gradually erodes the wall separating the exhaust passage from the water jacket. Once that wall breaches, water back siphons into the engine cylinders when the boat shuts down and exhaust pressure drops. Water does not compress. The next start attempt hydrolocks the engine, the pistons cannot complete their stroke, connecting rods bend, and the block is destroyed. Marine technicians across the segment place the cast iron riser service interval at 300 to 400 engine hours, with saltwater operation compressing that timeline significantly. A go-fast boat of this era, without documented riser replacement history, is carrying a complete loss liability priced at several times what riser replacement costs. Pull the risers, examine the casting walls, check for water weeping at the joint. If documentation does not exist, price the replacement into your offer. The second configuration involves a structural failure mode that shows up most frequently in inboard V-bottoms from the late 1980s through the late 1990s. It appears most often in boats that spent significant time on freshwater lakes without proper bilge drainage maintenance. During that era, builders bonded fiberglass tabbing over plywood structural members, including stringers, bulkheads, and sole supports. The failure begins when bilge water is allowed to stand. Improper drain tube installation, a single clogged limber hole, or an unsealed penetration creates a continuous moisture source directly against the plywood. The plywood does not rot evenly or obviously. It rots from the inside, maintaining enough surface contact to look sound while its core has turned to pulp. Owner restoration documentation from performance boating forums has confirmed the same sequence: drain tubes not functioning and water pooling in forward sections, with ROT starting in stringers adjacent to the fuel tank before progressing aft. A moisture meter and a full mechanical survey of every stringer and bulkhead penetration are non-negotiable on any inboard V-bottom from this window. Flecks underfoot and brown discoloration at stringer bases are the visible indicators. By the time those appear, the repair is already a major project. The third configuration to avoid is any high-performance stepped hull boat purchased without prop and drive height verification from a certified technician. Each step aerates the running surface to reduce friction and increase speed, but the geometry only works correctly within a narrow band of propeller pitch, drive height, and trim angle for a given power package. Owners on performance boating forums have documented buying a specific model and power combination expecting published sea trial results, then finding 10 to 15 miles per hour missing because the drive height and propeller pitch were mismatched for their actual weight and fuel load. The boat was not defective. The setup was wrong. A marine technician who specializes in high-performance drives can assess the X dimension, prop pitch, and blade geometry before purchase. That assessment costs a fraction of what a full prop package costs, and it eliminates the most common source of buyer disappointment in this category. If you have made it this far, please subscribe. The best configurations on this list represent exactly what the go-fast industry learned from those problems. The first best configuration is the Cigarette Racing Team 515. Founded by Don Aronow in 1970 and still built in Miami, Cigarette is the benchmark the entire go-fast segment measures against. The 515 is 51 feet 5 inches long with a 9 foot 6 inch beam. Its deck uses a carbon fiber vacuum-bagged sandwich construction that delivers over 1.7 times the flexural rigidity of conventional construction methods at a fraction of the weight. The air intakes alone, which run over 7 feet long and 14 inches wide, weigh 4.4 pounds. The carbon fiber structure is used throughout the hull, forward bulkheads, cabin liner, and engine hatch. In collaboration with Mercedes-AMG over 11 consecutive years, Cigarette has released 9 joint special edition models, with the 515 Project 1 reaching a documented top speed of 140 miles per hour, running twin Mercury Racing Quad, Cam V8 engines at a combined 3,100 horsepower, twin 22-inch Garmin touchscreen displays, IP67 rated push-button switches, and CNC machined triple anodized aluminum components throughout the cockpit complete a build that is not competing with other go-fast boats. It is simply in a different category. The second best configuration is the Donzi 38 ZRC. Donzi was founded by Don Aronow in 1964, and the ZRC hull carries that lineage into its race-proven running surface. Iconic marine group. Blueprinted the original two-step 38 ZRC hull when they returned it to production. The term meaning the hull form was optimized for its specific weight, power, drive, and propeller application, down to strake location measured in fractions of an inch. The hull and deck are hand-laid using vinyl ester resin with high-density foam coring. The transom is cored with high-density Kusa composite, and composite sandwich material is used for all stringers and bulkheads, no wood anywhere in the structural grid. Boating Magazine documented a top speed of 116 miles per hour in testing. The same boat later recorded a routine 120 miles per hour as the setup was refined. The sit-down cockpit lowers the center of gravity compared to stand-up bolster configurations, and the twin canopy windscreens create a driving environment described by the magazine as akin to being tucked into a high-performance sports car. The third best configuration is the Fountain 47 Lightning. Fountain Powerboats was founded by Reggie Fountain, who won 101 of 201 professional offshore races. In 2004, he set a V-bottom kilo speed record of 171.88 miles per hour on the Pamlico River in a 40-foot fountain. The 47 Lightning runs the twin-step super-ventilated positive lift bottom with twin strakes, a 14-inch deep notched transom, and a pad at the keel, a hull design documented by Poker Runs America as climbing on plane in 4.9 seconds and cruising at 51.8 miles per hour at 3,000 revolutions per minute. With twin staggered Mercury Racing dual-cal 1350 and 1550 engines, the 47 Lightning has a documented maximum horsepower rating of 3,100. The cockpit seats 7. The air-conditioned cabin includes a galley counter with sink and refrigerator, plus an enclosed head, a Garmin 8616 multifunction display, and a Mercury Vessel View 703 monitor the engine bay. The 47 Lightning is what happens when the most decorated V-bottom racing program in the history of the segment builds a production boat. The fourth best configuration is the Fountain 34 Thundercat. Fountain introduced the positive lift hull step design in the 1990s. The 34 Thundercat applies that engineering to a power catamaran platform, hull and deck formed from infused composite in a vacuum-bagged process, producing a fully rigged boat weighing approximately 5,400 pounds. Twin Mercury Racing 450R outboards provide documented top speed testing from speed on the water at 133.3 miles per hour in crosswind conditions with a full tank of fuel. The hull has a pair of steps, 3 pronounced lifting strakes, and 15 degrees of overall decrease, with the most inboard pad section carrying a slight concave shape that allows the boat to heel into turns with the predictability of a significantly larger hull. The cockpit accommodates 7 passengers across 4 bucket seats and a 3-person aft bench. Stainless steel components are used throughout for saltwater resistance. The 34 Thundercat enters the sport catamaran segment at significantly lower pricing than most competitors, while delivering documented performance that exceeds many of them. The thread running through every entry on this list is the same. The worst configurations are not poorly engineered boats. They are boats where mechanical and structural decisions standard in their era create predictable, documented failures when time, water, and deferred maintenance work against them. The best configurations are where every one of those vulnerabilities has been directly answered, with composite stringers instead of plywood, outboard power that eliminates exhaust risers and drive geometry complexity, and construction methods proven in offshore racing before they ever reached a production deck. Knowing which side of those lines a specific boat sits on is the only question that matters when evaluating a go-fast boat, and now you know exactly where every line is drawn.